Hello again. This is page one of our lesson for Wednesday, which is number 67. We're up to 67. And it's factoring completely is what it's called, which means we're going to see exercises with a combination of all the things we've learned to do regarding factoring. Here's a list of the recipes we've learned so far: the difference of squares, difference of cubes, sum of cubes, and the perfect square trinomial. And this plus minus here means, it could say plus or minus there. And if it says plus there, you use plus in there. And if it says minus there, use minus there. Well, this general strategy, this is common knowledge once you get to a certain point, and just common sense. First, you look for, is there a GCF? If there's a GCF, you factor it out. That leaves you with a simpler expression to continue with. Then it's a matter of how many terms are there, 2, 3, or 4 terms. If it's 2 terms, look to see, is it a difference of squares that I'm looking at? Is it a difference of cubes, or is it a sum of cubes? And of course, if it's one of those, you use one of those patterns that you see at the top of the paper. And hey, if it's a sum of cubes, remember, if it's a sum of, if it's a sum of squares is prime. It doesn't factor. You can just write prime as your answer if it's a sum of squares and if you've explored every other possibility. Now, if there's 3 terms, you might spot it as being a perfect square trinomial. You don't have to, but it will speed things up. If it is a perfect square trinomial, you'll get it factored quicker that way. You can always use the AC method. You can always use trial and error. That's what that stands for. And the AC method, remember, would be overkill for something like this. Do we need the AC method here? No. When A is 1, all you need are 2 numbers that add up to 7 and multiply out to 10 in this example. X plus 2, x plus 5. If you use the AC method, you're going to say 1 times 10 is 10, and you're going to look for numbers that multiply out to 10 and add up to 5. Same thing we did. You're going to get the same answer, but you're going to do a lot of extra steps. Now, if you have 4 terms, then you apply factoring by grouping. And if the grouping doesn't work right away because of the order that was handed to you, rearrange the terms and try again. Don't immediately say, oh, it's prime, because it might be, but it might not be. If you just rearrange the terms, you might find a way to factor it. So now we're going to try these examples. For this first one, I see common factor of 2 and also the a. I can write this 2a times what? X squared minus 49. Does that look appropriate? That's 2ax squared minus 98a. And now I see 2 terms in there. I'm inside this world of the parentheses. I see 2 terms. And I also see that it's a square minus a square. That's the square of x. That's the square of 7. So my answer is too many words to say, but there you see it. That times that times that. Okay? And that's number 1. So down to number 2. Is there a GCF? 3. 3 times x cubed minus 8. Again, I see 2 terms. Is it a difference of squares? No. Is it a difference of cubes? Yes. X to the third, that's 2 to the third. And then remember, for difference or sum of cubes, you can use SOAP to get the signs incorrectly. So the S stands for same sign. We use the same sign that appeared in the thing we're factoring. O for opposite. The next sign will be the opposite of the first sign. AP for always positive. This one is always positive. And then that's A, B. That's A squared. That's A times B. And that's B squared. what goes here? X and 2, and then x squared and 2 squared is 4, and then in the middle, 2 times x. Are we good? I think so. Number 3. Oh no, fractions. Oh, well, it's not that big a deal, is it? There is no GCF here. This is the square of 2/9. If you square a fraction, you just square the top and you square the bottom. So if you want you see what this is a square of, think what's the square root of 4? What's the square root of 81? And this is the square of 1/10. 1/10 squared would give you 1/100th. Okay, and of course there's an x there also. So I'm ready to write the factorization, make one of them plus, one of them minus. What goes in here? 2/9 x plus 1/10. 2/9 x. Oh, I'm sorry, I made them both plus, didn't I? 2/9 x minus 1/10. Okay, difference of squares pattern. Going up here now. Where are we? Right there, number 4. That's not a perfect square, that's not a perfect square, but wait, we didn't check for a GCF yet. There is a GCF of 5. I can write 5 times x squared minus 80 divided by 5 is 16. Aha! Now we've got a difference of squares again. And I hope this is obvious. Square of x, square of 4. So I write x minus 4, x plus 4, and we're done with that. This looks backwards. Should we leave it that way? Yes, because it's subtraction, and you can't change the order of subtraction. Is there a GCF? 3 comes out. 3 times 25 minus x squared. Now I'm looking at a difference of the square of 5 and the square of x, and all I have to do is write my answer. And important to keep this order of subtraction is the square of 5 came first, so the 5 goes first, and the x goes second. So if we wrote x minus 5, that would be the opposite number. Think about if you plug in a 7 for x, for instance. 5 minus 7 would be -2, but 7 minus 5 would be +2. Can't both be right. The one that's right is the one that we were given. And this monstrosity, this is the square of n squared w squared, right? If you square that, what do? You multiply both exponents. 2 times 2, you get both to the 4th power. And this, of course, is just a 9 squared. So I'm going to write n squared w squared minus 9, n squared w squared plus 9. How many people think we're done now? Yes, that's right. We're not done yet because this is a perfect square also. This is the square of nw minus the square of 3. This is a sum of squares. That doesn't go any further. But this, I can rewrite this, nw minus 3, nw plus 3, n squared w squared plus 9, and then there was nwa, but that's a whole other story. There's this factored as much as possible. Remember, this stops right there because it's a sum of squares. That's the end of page 1.